What would happen if a massive asteroid collided with our planet? In this video, we'll explore exactly this topic. 65 million years ago, enormous meteorites wiped out the dinosaurs, changing life on our planet forever. But what if a similar asteroid struck today? If you want to stay updated with more scientific and technological simulations like this, don't forget to like this video and subscribe to the channel. In the first scenario, a 100 kilometers diameter meteor from the far reaches of the solar system enters Earth's gravity and is headed towards Earth. The asteroid slams into the Sahara Desert at over 70,000 kilometers per hour. Temperatures at the point of impact reach tens of thousands of degrees Celsius, instantly vaporizing rock, sand, and everything within hundreds of kilometers. The pressure wave radiates outward at supersonic speeds, flattening cities, forests, and mountains. In an instant, a crater over 500 kilometers wide and 50 kilometers deep is carved into the Earth. The blast is so powerful that it registers as a magnitude 12+ earthquake on seismographs across Europe and Africa. Molten rock and vaporized sand rise in a cloud reaching the stratosphere, darkening the skies for hundreds of miles. Lightning storms ignite spontaneously within this cloud, turning the atmosphere into a deadly storm of fire and electricity. The devastation spreads far beyond Libya. Tunisia, Egypt, Sudan, and parts of Algeria face catastrophic shockwaves and massive firestorms. The Mediterranean's coastal cities are hit by tsunamis hundreds of meters high. Entire ecosystems vanish in minutes. The eastern and central Mediterranean seas begin to evaporate locally as heat from the impact disrupts ocean currents. Water flow through the Strait of Gibraltar is choked, and the Black Sea stops receiving replenishing water, triggering ecological collapse in both seas. Italy and Greece experience massive earthquakes, infrastructure collapses, and atmospheric shockwaves that knock down buildings. Dust and aerosols released into the air create a temporary nuclear winter, blocking sunlight and causing sudden temperature drops across Europe and North Africa. The Middle East is next. Iraq, Syria, and Saudi Arabia face unstable atmospheric conditions, sudden heatwaves, and massive dust storms. Agriculture collapses almost overnight, threatening the survival of millions. Water supplies from the Nile and other rivers are disrupted, leading to unprecedented famine risks in Egypt and Sudan. Turkey, Bulgaria, and North Macedonia face earthquakes, landslides, and regional floods. Coastal cities are battered by massive tidal waves, while inland areas face infrastructure destruction and fires. No one escapes the chaos. From the deserts of North Africa to the mountains of southern Europe, humanity faces the ripple effects of this singular cosmic event. The human toll is unimaginable. Millions die instantly from the blast. Hundreds of millions more perish from fires, tsunamis, and collapsing infrastructure. Within months, billions could face starvation as global food supplies crash due to blocked sunlight and ruined farmland. Entire nations could become uninhabitable. Cities disappear from maps. Coastlines reshape. The Mediterranean ecosystem collapses, killing marine life on an unprecedented scale. Humanity is forced to adapt to a world where survival becomes the only goal. But the disaster doesn't stop there. Tons of debris and pulverized rock from the impact are thrown high into the atmosphere, raining down on the eastern and central Mediterranean, and even the Red Sea. These seas begin to fill with impact debris, their waters evaporate, and entire marine corridors dry up. The Strait of Gibraltar is blocked, cutting off maritime connection to the Atlantic. The Red Sea's link to the Mediterranean is destroyed, closing off the Suez route and disrupting global shipping. Entire bodies of water vanish, leaving deserts where once there were seas. From a scientific perspective, the impact is staggering. A 100-kilometer asteroid carries the energy equivalent to billions of megatons of TNT. The crater formed is over 500 kilometers wide, 50 kilometers deep, and the surrounding terrain is molten. Pressure waves crush the land, generating earthquakes felt thousands of kilometers away. Atmospheric shockwaves ignite massive firestorms, while dust and aerosols remain in the upper atmosphere for years, blocking sunlight and triggering long-term climate change. The Mediterranean's circulation patterns collapse, causing ecological chain reactions across Europe, Africa, and the Middle East. In short, a single asteroid of this size doesn't just destroy a region, it reshapes the planet. Now, imagine one of the largest cosmic objects ever, a 100-kilometer wide asteroid, a mountain of rock and ice, hurtling through space at hundreds of kilometers per second, entering Earth's atmosphere. The sheer size and velocity of this rock make it a planet-altering threat. From the far reaches of our solar system, countless cosmic travelers race through the void. After witnessing the unimaginable devastation in Libya, what if another cosmic giant struck elsewhere? This time, a 100-kilometer asteroid hurtles toward the Horn of Africa, Somalia. The consequences? Far beyond imagination. The asteroid slams into the Somali coastline with velocities exceeding 70,000 kilometers per hour. Instantly, a colossal crater begins to form, stretching up to 1,000 kilometers in diameter. The heat at impact reaches tens of thousands of degrees Celsius, vaporizing coastal land and seawater alike. The pressure wave radiates outward, flattening everything within hundreds of kilometers. Massive amounts of soil, rock, and molten debris are ejected into the atmosphere, forming a cloud that spans thousands of kilometers, blocking sunlight and darkening skies across Africa and beyond. At the impact site, new land rises from the seabed. The crater walls form giant ridges of dry, hot terrain. Inside the crater, temperatures soar, turning the newly formed land into a molten desert. Around the crater, tidal waves engulf the coastline, reshaping the ocean floor and creating sudden new islands. The impact doesn't just affect land, it transforms the oceans. The asteroid displaces enormous volumes of water, pushing the Indian Ocean inland toward Africa's central plains. Entire new seas form, flooding Central Africa, creating lakes and inland seas where none existed before. Simultaneously, ocean water spreads northward, covering parts of Iraq, Syria, and the Arabian Peninsula. Coastal regions disappear under hundreds of meters of seawater. The immediate vicinity of the crater becomes a dry, scorching landmass, while surrounding areas are engulfed by the sea. Atmospheric pressure rises dramatically, generating shockwaves felt thousands of kilometers away. Huge amounts of water vapor and debris enter the stratosphere, forming a global-scale cloud. Sunlight is blocked, temperatures fluctuate wildly, and storms rage across continents. The world enters a climate chaos unlike anything ever recorded. The human cost is staggering. Millions perish instantly from the blast and tsunami. Hundreds of millions more are displaced as new seas engulf cities, farmland, and infrastructure. Within weeks, billions face famine as sunlight is blocked and crops fail across Africa, the Middle East, and South Asia. Entire regions of Somalia, Ethiopia, Kenya, and coastal East Africa become uninhabitable. Cities vanish, coastlines are rewritten, and entire populations are forced to flee. The combination of heat, pressure, and flooding creates conditions where survival becomes the primary concern. The crater itself radiates heat across the region. Temperatures inside the newly formed landmass reach thousands of degrees, while air pressure surges, triggering regional earthquakes and triggering massive seismic activity along Africa's Rift Valley and beyond. Geologically, the asteroid reshapes the Horn of Africa forever. Crater walls rise hundreds of meters, creating new ridges and mountains. Surrounding ocean waters carve out new coastlines, and Africa's central plains are now flooded, forming a sea that stretches thousands of kilometers inland. The Red Sea partially dries or changes course due to displaced sediments. Somali coastal waters solidify into new land. Surrounding ocean currents are disrupted, impacting marine ecosystems across the Indian Ocean. Coral reefs vanish, fish populations collapse, and oceanic food chains are destroyed. A 100-kilometer asteroid hitting Somalia doesn't just devastate a country, it rewrites geography, reshapes oceans, and forces humanity to confront survival on a global scale. From dry craters to newly formed seas, from displaced populations to climate chaos, the Earth would never be the same again. Could humanity endure such a transformation? Write to comment. The Earth has faced countless cosmic threats in its long history, and today, we've imagined just two of the most extreme scenarios. From Libya to Somalia, from unimaginable impacts to seas reshaped, these simulations remind us of the fragility and resilience of our planet. If you want to see more simulations like this, or explore other cosmic what-ifs, don't forget to like this video and subscribe to the channel. And if there's a specific asteroid strike or planetary scenario you'd like us to simulate next, leave your ideas in the comments, we might bring your cosmic vision to life. See you next video.